Hello everyone, my name is Zhang Ting. Today I will present our work, Sentiment Analysis for Software Engineering. How far can pre-trained transformer models go? This is a collaborative work with my teammates, Bowen, Ferdian, and Stephens, and my supervisors, David and Lin Xiao. In each work, we focus on the problem of sentiment analysis for software engineering. We conducted an extensive comparative study among prior existing tools and fine-tuned pre-trained transformer models. Here is the motivation of our work. Software developers show emotions across different software artifacts. Here are two examples. First is on Stack Overflow. This is a question body. It's simple to use and concise. It is not bloated. This sentence actually shows positive sentiment. The other example is from GitHub. Here is a pull request from Transformers repo. I fully agree on adding tests for the trainer. I put this immediately on top of my to-do list. This sentence also shows positive sentiment. There has been extensive research on sentiment analysis for software engineering. Previously, researchers usually use general-purpose tools. For example, Stanford CoNLP, which was trained on movie reviews. SentiStrength is a lexicon-based tool, which is specifically designed for informal short tests on social media. Afterwards, some software engineering-specific tools have been proposed. For example, Senti4SD and SentiCR are two supervised learning-based tools. SentiStrength SE, which was built on top of SentiStrength by adding some software engineering-specific lexicons. In recent years, pre-trained transformer-based language models have brought considerable breakthroughs for natural language processing. Among them, BERT, Rebecca, XLNet, Albert have been widely used in the following work. In this work, we want to answer one main research question: how well can pre-trained transformer models perform for this SFVC task? Specifically, we answer two research questions. How accurate are transformer models as compared to existing SFVC tools? How efficient are these transformer models compared to existing SFVC tools? We refer to the fine-tuned pre-trained transformer models as the transformer models in the following slides. Here's a diagram of our study. The main task is sentiment analysis for software engineering. We want to apply pre-trained transformer-based language models, specifically BERT, Rebecca, XLNet, Albert. We compare them with general-purpose tools and SE-specific tools. We formulate this problem as a text classification task. Given a text unit in software artifact, we need to detect its sentiment polarity. One part of the related work is the SFVC Studies. There are 3 benchmark studies which have been published in year of 2018. These 3 benchmark studies have compared several tools on several datasets, usually 3 or 4. On the other hand, pre-trained models for NLP. The first generation is word embeddings, for example, word-to-vec glove. Much software engineering research has applied this technique. However, for the second generation, contextual word representations, there is none work has applied this technique to SE-related research. Here's our methodology. We collectively refer these 5 tools as a prior group, and we collectively refer these 4 pre-trained transformer models as the PTM group. These 5 tools have been highlighted because they have either been retrained or fine-tuned on the training data. All of these 9 methods have been tested on the tested data. Overall, we adopted 6 publicly available datasets. We split each dataset into 70% for training, 30% for testing. They come from Stack Overflow, app reviews, GitHub, and dry issue comments and code reviews. Here is the detail of the datasets. As we can see, they have different sentiment polarity proportions. Here is our evaluation metrics. For each polarity, we calculate precision, recall, and F1 score. And we also calculate macro and micro metrics. Here is the formula. Here is the evaluation result, the accuracy. As we can see, the best performer in the PTM group has a substantial improvement over the best performer in the PRI group, both on the macro averaged F1 score and micro averaged F1 score. We highlighted the best performance in PTM group. As we can see, the best performance are different across different datasets. We also compare the efficiency of these two groups. Generally speaking, the fine-tuned pre-trained transformer models cost more time than CNT-CR, CNT-Strength, and CNT-Strength ACE, but it costs less time than CNT-4SD and the Stanford Co-NLP. From the empirical result, we find that fine-tuned pre-trained transformer-based models actually can achieve better performance than prior existing tools. We highlight 4 future work. The first one is that we believe more efforts should be put in assigning sentiment labels, as the ground truth play an important role in this task. Secondly, we want to try a hybrid method to compose different solutions to further boost the performance. Thirdly, we want to apply the transformer-based SFVC tools for further downstream tasks, for example, API reviews recommendation. Lastly, we also want to investigate how the transformer-based models perform for other software engineering tasks. Thank you for listening. We release our replication package here. If you have further questions, feel free to contact me. Thank you.